Happy Friday, everybody. Didn't that come quickly? No? I know, but some people are still like, too long for me. All right. Okay, here we go. Answers to the evens. We're checking our homework from last night, and then we'll see if anybody has other questions. I'm guessing we don't have too many, but there might be a couple odds you guys want to see worked out. And if you didn't take a picture of number 32 from yesterday, fail, why not? But you'll see it worked out in a second. First of all, you guys had numbers 1 through 6. Of course, you could check them in the back for the odds, but I just gave them all because it was easier to take one picture instead of 3. Tangent, sine, cotangent, cosecant, cotangent squared, negative cotangent. The question, did you put the u's? If not, get those u's in there. You have to have an argument. Otherwise, remember, if you don't have the trig function with an argument, it's like this being in a problem. Does that make any sense? No, there's nobody inside. We have to have an argument for these extra things like square roots, like trig functions. You have to make sure you're putting the u's or whatever variables. David. Oh, you're good. Oh, maybe you just looked at the wrong formula and plugged in over. Oh. That makes sense. It's possible. It's easy to get these things mixed around, especially as you guys are still studying them. Oh, studying them! What are you supposed to be doing with the formulas? Flashcarding them? Quizleting them? Spreading it out so that you don't kill yourself the night before with like 50 formulas? Just kidding, more like 35 you have to memorize? For the problems, but remember the first part of the test, eventually. Eventually. End of chapter 5. Eventually there's going to be a formula part as well. Number 32, if you need to see it again, that's the only other even. Although I did put the bonus on here if you guys tried it. Number 32, you had to substitute because we cannot factor right now. They're different, but we can use a property. Now we're like, yay, only cosines and constants. Reorder it. For a lot of you, it would have been easier just to pull that negative out because who likes negatives in a quadratic? You have to factor. And then you could have gone ahead and said factors of 4, negative 4, that add to be negative 3, a minus 4, and a positive 1, the negative's on the outside. But, question, if some of you didn't pull the negative out, the negative is just inside somewhere. So maybe you have a right answer that looks differently than this one. Maybe you have negative cosine x minus 1 times cosine x minus 4. Remember, the negative can only go in one place because it's multiplication. Or maybe you have negative cosine x plus 4 times cosine x plus 1. Just FOIL it and make sure that everything works out. It doesn't have to look exactly like this. Number 48, if you tried the bonus, I want to peek at it. There it is. If you want to peek at it, you just give a couple seconds. It was a fun problem. If you like these puzzling ones, trying to figure it out. You had to get, I'm just going to walk through the steps, get a common denominator, multiply this one, cosine over cosine, this one, 1 plus sine over 1 plus sine, you end up here. Can't really do much until you're like, wait, square, I can do that, let's FOIL. Not killing a puppy. Outer, inner times 2, last. Then you would have to see, wait a minute, what's cosine squared plus sine squared? Addition is commutative, I could move this little addition over here. Sine squared plus cosine squared is 1. 1 plus 1 is 2. Ooh. 2 factors out. Boop. Factors reduce. Boop. 2 over cosine is 2 secant. Dun, 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 dun. Anyway, it was a fun problem, but I made it extra credit for only those who were courageous and willing in order to try. Kiddos, are there any odds that you would like to see? Caleb? 45. 45. Any other odds? I can't see your face. Who is that? Oscar? 51, 45, 51. Any other ones? Yeah. 55. Okay, the last 3. Just for sake of having it in the video, in case some of you guys want to reference it a little bit later, let's go ahead and write them down now. So we have 45, 51, 55. Do I have a volunteer willing to come up to the smart board? I know, the smart board. I'll let you orient it first. That way it's not all messy. Yep, definitely. And do number 45? David's up. Hold on. Hit both buttons first. At the same time. Hold. There you go. Tap in the inside just so that's all nice and oriented and you don't have to worry about it. There you go. Okay, do I have someone on deck for number 51? Maddie, it's all yours. Number 55. Oh, come on. People will be brave.
I'll try it.
Ricky will try it. We'll guide him. We'll work together as a class. All right, go ahead, baby. You guys can get your notes out and get it ready because we're going to section 5 too. But please feel free to follow along.
I don't like that.
Section 5 too?
No.
Oh, number. Let me see.
Forgot about this.
Oh, it's the plug and chug one. You guys got scared of the plug and chug? Yeah. Fairly straightforward, right? If you don't want it, I can do it. So you see what I mean by plug and chug, right?
Yeah.
And then you have to square it, so then the 2 secant will become what? 4. Then there's 4s in both, you can pull out. Square root of 4 is 2, so 2 comes out.
Square. Or
Secant squared. Secant squared, right?
yeah.
Secant squared minus 1. Does that make sense? Square root of 10 is square root of 10. We'll get there. I think it's just like a motivational talk, like don't lose motivation second semester. Which isn't bad, like everyone needs to hear it, they need to heed it. Alright. What did he do, guys? How'd he go from here to here? What was he trying to get? A common denominator. So the one step that he could have added in, but he kind of did it. Some of you can do this mental math, and I am totally cool with that. But technically, if you want to see the work for it, what would he need to multiply this one by, top bottom? The other one, right? Don't worry, I got this. Multiply by the other denominator. Yeah? And what would this one need to be multiplied by over here? Yeah, the other one, right? And then maybe you can see how when he multiplied on top, he got this first, plus the addition needs to stay. Multiply on top, he got the second. We need to put our parentheses to remind us that these are quantities being multiplied. And that's where this common denominator came from, a negative cosine, a positive cosine. We're missing a plus, right? No, you're okay. It's so easy on the smartboard just to miss something. There we go. And 1 plus 1 is 2. 1 minus cosine squared is sine squared. 2 over is cosecant squared. Does that make sense, all mine that had questions? Cool. I'm just going to, for sake of argument, to make a point, put in all my parentheses real quick. Okay. Start coming on down for number, what's the next one, 51? Oops, nope. There we go. Yeah. Go ahead, man. Which becomes outside square root 2. Inside is the 2 came out. Nice one. Square root of tangent square. And put little. Now, I know it's a little ways away, but remember, quiz is coming. So even if you kind of got it in homework, maybe you kind of had to use Calc Chat for these on. They get kind of tricky at the end. Look at it, kind of try to look at it for the first time again and be like, okay, so I'm looking at it. I can't really do any addition. I think I have to plug in some stuff. What's the name of that property Maddie's plugging in right now? Cosine over sine? What type of property is that?
Quotient.
Quotient property. Yeah. Quotient property for cotangent. Cofunction ones and the even odd ones are only used rarely. That's why, like, on the big formula part of the test, eventually I might ask you one or two of them just to make sure you studied, but they're not as important as the other ones. I should say as common. That's a better way of saying it. Now, if you're trying to kind of think about it mathematically and know if you could do it again if you needed to, there's an addition and one part has a denominator. Changing. I was telling them to debunk you. I know, hang in there. I should. It's a great idea. Just like randomly. I used to have like a squirt bottle of water and I used to have lots of fun. I could just go up next to him and
I want to tape
I feel like
it.
that's kind of, or like throw an eraser, but now I can't do that anymore.
Oh yeah.
I want to tape one under your teacher's chair.
Take what? Nail? It's like a whoopee cushion.
Mrs. Rainier, that.
She would react.
Yeah.
That'd be funny. But you don't want anyone to get hurt because they might, they're sitting down.
Yeah.
Poor guy, he's already suffered.
This is really
You guys were at that spirit day, right?
Yeah.
The two-way one.
Well, my
But
sister,
you were on that side?
No, we weren't in there, but my sister took a video because she was taking a video and she hacked like,
Yeah, that's right. There was a
got
video
it.
going around.
And she gosh, like she
He was
just
half to death.
still
If you notice, he's on the ground. He's not up there anymore. He's not during big ball. And like, if you notice teachers, like, stand in front of him during the big ball one. We love tools. We love work out. All right, so the first step was plug in. Then it was simplify. Then it was common denominators. I was just starting to introduce that one. We had to get these two pieces together. Then we got the Pythagorean property, cosecant. Perfect. Thank you, Maddie. Okay, so we had David for this one, Maddie for this one, and then, Ricky, you ready? Last one, number 55. P.S. If you guys are writing this down, it should be in a colored pen because you're correcting, right?
It's really distinct.
Okay, as long as it's distinct. As long as it's distinct.
Black, this is gray.
Yeah. Equals X. Secant theta equals X. There you go. Okay, so the name of the game is Plug and Chug, right?
Oh, yeah, it's two.
Oh, yeah. Good call.
It was just.
See, if you guys notice, it's a struggle to stay out of like the shadow of the smartphone. Yeah. You're like, wait, I don't know where it is.
Wait, would that just be writing on your back?
Kind of, yes, but no. Wait, where'd that 2 come from?
I don't know.
He pulled out the 4, and the square root of 4 is 2. So to pull it all the way out of the square root, pull out the 4, square root of 4 is 2. So he was able to pull it all the way out by square rooting. Nice.
Fight him.
I got it. There you go. Why the absolute value, my kiddos that knew it was supposed to be there?
What is square?
Yeah, if you plug in this, a squared is positive, a square root of a positive is a positive. This is always positive. To maintain that, when the square root squared is gone, I have to put in the absolute value. Done, 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 done. Okay. All right, kiddos, thank you for the questions. Ooh, notes open. Here we go. Oh, 2 seconds? Okay, sorry. Oh, can you see it? You forgot the 1,000. Okay. right, section 5.2. Remember, we're just starting today. We get to work on it more Monday and maybe even more on Tuesday just because we can, because we want the quiz on Thursday. So I'll change the calendar this week, and that way you guys can, it'll reflect what's going on next or now. Before we get too far into section 5.2, at this very beginning, I just want to make sure we understand the difference. In algebra, just because you see an equals sign doesn't mean that the equations behave, act the same way. Doesn't mean that the equations behave or act the same way, because some equations are always true. Okay, focus, Jason. Some equations are always true, and some equations are sometimes true. Some equations are always true, and those we can call identities if we want to. And some equations are only sometimes true. Caleb?
How many lines should we skip?
Just two. Two's good. Which one, looking at these two, which one seems to be a sometimes, conditional or identity? Oh yeah, conditional, right? Think about it. If you have, if a bank is trying to give a conditional loan, does that work? That kind of works. What does that mean the loan has? Can everybody get it?
Conditions.
There are conditions that need to be met, right? Even though credit card companies want to make you think, once you grow up and start getting like adult mail, like responsible, you have to pay bills and you have to like, I don't know, deal with collectors and that sort of stuff. Not deal with hopefully ever, but okay. These banks try to come after you. As soon as you, I don't know, register to vote probably. And you get all these credit cards and like, oh yeah, you can get a credit card, no big deal. But for the good ones, there are always conditions that need to be met. For the bad ones, they love to take people in debt and make them more in debt. I don't know why. Just beware. Take personal finance. You'll learn a lot more about it. True. Personal finance does a good job, the curriculum does a good job warning you of the dangers. That doesn't mean they're always bad in the sense of wrong or sinful, but they can be very destructive to you and or any future dependents on you, including kids, family, parents. Just never have your parents co-sign for you. You might ruin relationships that way. Co-signing loans. Oh, that's true. Sorry, I didn't mean the mathematical. Anyway, conditional equations. There are conditions. Now, let me give you an example for algebra, first of all. X plus 2 equals 3. Why is that conditional? Because the x has to be 1. Anything else? No. It's only true when x is 1. David? Yeah. If you have time and want to be writing all of it, yes, but I will highlight the highlights. I'll highlight the important parts. So you could shorten it if you wait just a second. So conditional equation, x plus 2 equals 3, only sometimes true. Let me give you another example. What if I was to give you something like cosine of x minus 1/2 equals 1. Sometimes or always? Sometimes. Hold on, pause. That's actually never true. Don't use that one. Use plus, that's better. Change it, change it, change it. Cosine x plus 1/2 equals 1. How would you solve it? Subtract 1/2. Cosine equals 1/2. Does that ever happen in the unit circle? Ha! But only sometimes. Does that make sense? Okay. So conditional equations, they're equals for sure, but it's only sometimes true, and part of the whole algebraic process is figuring out when that sometimes is. Are. Maybe. Okay, identity. Identity. What if I was to give you something like, what's an identity? That's algebraic and not trigonometric. No, that's only sometimes true too. I was going to give you Pythagorean theorem, which is always true for a right triangle, but only sometimes true in the grand scheme of life. Yeah, I guess we could do that. I don't like that one, though. All right. We'll do an arithmetic example. How about that? We'll do an arithmetic example, because the algebra example, the whole point of algebra is that they're conditional equations you're trying to solve. Oh, well. The Pythagorean could be an example. If you have like a category like right triangles, you can have the Pythagorean theorem that is an identity for that entire category. But I felt bad because that's only sometimes true with right triangles only. True. But that's not necessarily a good thing. Because I need to teach you guys discernment, not just take whatever a teacher says and say and take it as truth. Because you're going to college sometime soon. And teachers make mistakes too, even the ones that believe in the Lord. So, identity. What's one with trig? Which one do you want to use? Let's do the one that's not rarely used. This is the reciprocal one, right? Identity. Why? It's always true. Always true. Always true. Always, always. Meaning, I can take tangent of 30 degrees, it's 1 over cotangent of 30 degrees. I can take tangent of 27 degrees, it's 1 over cotangent of 27 degrees. I can take tangent of 1080 degrees, it's 1 over cotangent of 1080 degrees. Doesn't matter. Any theta is true in that identity. So do you guys see the difference between equations? They all have equals. True, 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 true. Sometimes, always. Is it important in life to think about what things are only sometimes true and what things are always true? Forms your entire worldview. Huh? Without that basis, you can end up all over the place in a dangerous way. Relative versus absolute, but that's not necessarily today's lesson, but it is a life lesson to think about. Okay, here we go. Can I scroll down? This entire section is about identities, which is why you guys aren't seeing like normal algebraic equations with numbers, etc. Which is why we aren't solving for x equals theta equals, etc. Now that's coming. There are conditional equations coming, but first we need to get really good with these identities and how to take what's given and maybe put it in a different form that's more useful for us before we get to these nasty conditional ones. Now, I said I was going to go ahead and narrow this down just a bit, so let me get my highlighter. There he is. Let's do something exciting. Is that too dark, though? Can you see? Okay, let's do blue. I just made that up. All right. For verifying trig identities, you have to choose only one side. You have to choose only one side. Work with one side and one side alone. Now, you might choose a side and then change your mind, so you have to start over and choose the other side. It's totally valid. This entire section, I need you to think trial and error is a good thing. Trial and error is a good thing. But why does that not seem like a good thing in math? Yeah, trial and error, you're like, stink. I might try something and I'm wrong. But question, life lesson. Can you sometimes try things and they're wrong and you have to not give up? That's an important life lesson. Do you know what one of the biggest things our culture and all the advantages that it has with technology and with this, that, and the other, especially technology, it's probably one of the biggest differences in your generation than the ones prior. With all of the advantages, you know what one of the characteristics, character traits that is most lacking in this generation? Grit, stick-to-itiveness, perseverance. Why is it lacking? Think about it.
Because we don't need to. Everything's easy.
Everything's easy. Everything's fast. Now, is that true in life? No. But is that true in learning? Kind of. You have Wikipedia, which is not always true. Hopefully some teacher has taught you that in the past. You have the internet. You have... How hard is it to have superficial relationships? Friendships. So easy. You can like just video game and talk and be like, hey, yeah, we're best buds. And then be like, okay, what's going on in life? What are they struggling with? Oh, I don't know, but we play games all the time. Oh, great. Good friend. Right? We text nonstop about nothing. Oh, that's good. Glad it's a deep one right there. I have 400 Facebook friends. Cool. How many of them could you actually ask for help on something? It's rough, right? We're isolating ourselves with all the advantages, and as a result, we also are getting, I don't like lazy because that just denotes, I don't know, that has such a negative connotation, but perseverance is lacking. There's a study, and I actually learned this from Mrs. McRae. She's a new middle school teacher. There was a study, and I'm approximating because I don't remember the exact numbers. A class from Japan was given an impossible math problem. An impossible math problem. They sat down, they worked on that thing, and it took about, on average, 43 minutes. It was in the 40s. 43 minutes before they finally, after trying it and trying it and trying it, on average, the entire class, 43 minutes before they finally raised their hand, basically just gave up and were like, we don't know. We don't know what to do. An American class was given the exact same problem.
3 seconds. They looked at the problem.
Less than 3 minutes.
I'm surprised it took that long.
Now, that's on average. Of course, there were the ones that were like 2 seconds. But it looked like, wait. It looked like a possible problem. It probably was one where they could do a couple steps. But literally, 3 minutes versus 40, whatever I said. It was in the 40s. I'm approximating.
Or maybe there was a genius in each of us.
Maybe. But hold on, what does that mean in terms of life? Skills. Who's going to accomplish more when things get tough?
Obviously, David, the Americans, because we're not going to sit around bumming on one impossible problem. Like,
So you're just going to do what's been already done?
yeah, that's the
But we're gonna
same
do it well.
things.
Anyway, let's keep going. But I need you guys to hear me out on this because this section you're going to try and it's not always going to work the first time. Okay? So you have to be ready. Thank you. It's often better to work with the more complicated side. If you can choose a more complicated side, it's better. Okay, number 2, look for opportunities to math. What? Oh, come on, that's the new thing, right? Like make a noun and pretend it's a verb. Let's math, right? What do I mean by math? Let's do stuff from section 5.2. Maybe factoring. Maybe common denominators. Maybe squaring stuff. Maybe, oh, that's another denominatory thing. More common denominators. I want you guys to go ahead and put in parentheses really quickly section 5.1. Section 5.1. So what you did in 5.1, that's math. The different directions they gave you. 5.1 math words, the keywords. Number 3 says, hey, let's do some identities. Use the chart from 5.1. Look to the identities. So number 2 and 3, it's not so much there's a perfect order. Number 1, you do have to do first. 2 and 3, you're looking, can I math? Can I do math? Number 3, can I plug in? You're just kind of having to choose like you did in section 5.1. Maybe, I'm going to say note the final expression. You can look at the other side that you're trying to make it match. You can look at the other side and try to have that kind of guide where you go. If worst comes to worst, try converting everything to sines and cosines. If there are tangents and cosecants and secants, if you can't see, nothing you're doing is working out, just take everything, go to sines and cosines, and then start over. And then number 5, this is the step that needed that little pep talk, or maybe at least informational life lesson-y talk about. Always try something. Try something. Maybe it won't work out for you. Maybe someone else can make it work out. Maybe what you try is the hard way, and when it gets hard, you're like, okay, let me try and see if there's a more efficient way, a faster way. Maybe you'll get stuck because you did something illegal, and so it's not going to work out. You have to go find your mistake. Even making an attempt that leads to a dead end can provide insight. There are so many examples from science, but we're just going to go ahead and stop right now. Thomas Edison. Anyway. I'm sure your science teachers have talked about this with you. Okay, we're not going to be able to do much more. Oh, you guys, we still have silly goofs. We still have like 6-7 minutes.
I said I would give up like what?
Oh, okay, that makes way more
We
sense.
have 11 minutes.
Stressed me out. Oh yeah, we have tons of time.
3 minutes, and then after that I'll give up.
Do you guys need more time to write down then?
Yes.
All right. David does.
Alright, thank you.
There you go. Keep going. It's okay. I was just gonna rush if we had like 1 minute to show you the idea. All right, focus on it. You should be taking notes. Come on, guys. A few of you have been distracted most of the class, and that's a bummer. Stuff to be learned, not only math, hopefully. If all I talk about is math, it's kind of sad.
Mr. Shanks used to talk about Mormonism.
We can try that.
We could try that. He knows way more than I do. I didn't go on those mission trips in college. He did.
He has family members.
He's like close ones, like first cousin.
Yeah.
That's some good conversations. Because peppered all over the internet, you guys just writing anyway. Some of you can multitask and listen, the rest of you, oh well. But isn't it like a common joke? What's the most common joke with kids who are tired of the math they're doing in high school or junior high? Yeah. When am I going to use this?
Oh, yeah.
Right? What's the best answer? Not the funniest, not the silliest, not the
If you want to get
laziest.
rich, you get a math job.
Okay, well that's a good one, but
The guy that said, the guy that's,
yes.
Wait, what was it?
You're never going to use it, but it helps you with your critical thinking.
Now some people might use it, that's very true. How does it help you with your critical thinking and problem solving?
You're solving a problem.
You're solving a problem, you're hopefully developing perseverance and grit, but you're also developing...
You won't stop at
I know, that's the one thing Caleb won't stop after. Having a math degree, even for things like medical school, is looked, not that you have to do it in college, I'm not going there per se. But what I am showing you is just a general thing that the workforce, employers, and people accepting, like looking at the quality of a student, they highly value someone's performance in math. Not that it's the only thing, not at all, but they highly value good performance in math because it shows that you're able to think through a problem, solve through a problem, take a new type of problem, apply what you do know to that problem. And that's life skills in any field that you go to. Most fields that you go to, I should say that one. There are just a few that do reward pure creativity, that's true. But a lot of fields, you have to be given a situation, sometimes thrown a situation, because real life is messy in any field that you're in. And you need to be able to take what you know and apply it to this new, weird, kind of out there sort of situation and problem solve all the time. Anyway, something to think about. You guys got it? Okay. Few extra notes, just because I like that table, but I also have my own little, like, thinking through this too. Sometimes it's useful to transform. That's what we've been doing when we plug in identities. JJ, I know, it's hard, but it's Friday. Come on, bud. I can make you stand. You don't want to do that. I know. Useful to transform, transformers, trig expressions into a form that is more useful algebraically. What is a great example of that? Number 32 in homework. What? You had a sine squared, you had a cosine, you had a number. You couldn't algebraically do anything until you got the squared to be a cosine squared de facto. So sometimes you might have to look and say, I can't do math yet, but I could if only. That might also apply to things like common denominators. Oh, there's an addition, but I can't do it. They don't have common denominators. Oh, but if I get a common denominator. So anyway, always keep your algebra skills, your wits about you. Second one, you cannot assume the two sides are equal when verifying so. I'm going to write this on the computer. Ooh, that's big.
do I mean by this? It's a super common mistake I see all the time, especially when there are things in the expression like square roots. You guys are so used to algebra where if you see a square root, you're like, oh, hey, square both sides. You don't have both sides. You're not allowed to work with both sides. You can't square a square root. It's illegal if you're only working with one side. So you cannot undo division by multiplying. You cannot undo subtraction by addition. You cannot undo a square root with a squared or a squared with a square root. You cannot do anything that would require you to do it to both sides because you're only allowed to work with one. Now it's a bummer, you're so well trained, hopefully from algebra, that you're like, oh, square root, square it, it's gone. No, can't do that. And then the last one is just keep looking to 5.1 because those directions where they were telling you to factor to common denominators are all skills you might need. Okay, all of that gets us up to at least a couple examples, I hope. Do you guys need more time? Sorry, am I going too fast? I still see some people writing. What's different in 5.2? I'm about to change the page to an example. What's different in 5.2 is that there is an equals sign. In 5.1, gave you an expression. There was no equals, and you just played with the expression. That's why we weren't able to multiply both sides or add to the other side or square both sides, etc. You guys kind of saw some of that yesterday. Today we do have an equals, but we're showing, we're proving, we're verifying, not with geometric two-column proofs, with our math. We are going to prove that one side equals the other, and we're only allowed to work with one side like our step number 1 tells us in guidelines. Okay, here we go. P.S. With a couple examples we do, you could probably start homework, but don't try to do the entire thing.
Okay.
These get tricky. I know, right?
Don't have to tell us.
Well, I do have to tell you twice to start them.
Yeah.
Maybe 3 or 4 times. Okay, so, perseverance, grit. Be motivated. Habits you're forming today shape you for tomorrow. I don't know. Made it up, I'm sure someone wise said it once. Okay, 15. How I verify identities. And I want you to too. And the book does not do it, so I need you to listen. Draw a T. Draw a T. Why are people out? Draw a T. The T says, hey, we're splitting this into 2 parts and we're only allowed to work with what? 1. Okay. Work with one side. Choose the more complicated side. What do you guys think is more complicated? This one with 2 or this one with 1? Show you expression. This one with 2, right? So when we're working with 2, we have to say, when we're working with 2 sides, we have to choose the more complicated one, right? Okay, so if we choose the left side. The first step I want you to do, and it'll be worth half a point in any problem you face at high grade. Literally, just following you. You start by drawing a T and choosing a side, which you show by rewriting. Worth half a point. You lose it if you don't write it. I'm not kidding. Long story short of why, because I do have you guys write the problem. But some of you might start messing with it right away. And if you do something illegal, the very first step, you won't know how to go back and try to fix it. Okay. Now we have to say, can we do math? Can we subtract those 2? No, they're different, right? Okay, we can't subtract. Alright, can we square? There's nothing to square, it's just there. Can we plug in a property? Yes. But which one? Look at the other side. That's one of the strategies, the guidelines. Look at the other side. Sine squared is cool. Who's not? Cosine squared, I don't want him.
Oh.
Don't worry about the 2. Just look at, they have sine squareds, I have sine squareds. They don't have cosine squareds. See. Okay, well, is there a property that would let us get rid of the cosine squared?
It's copy.
Cosine squared of beta is?
Oh, it's 1 minus.
Yeah, the Pythagorean, right? Some of these are easy, some of these are hard. 1 minus sine squared of beta. What do you notice? Now do math. Are there any like terms that can combine?
2 sine squared. Both of them are negative, so I get 1 minus 2 sine squared. Now, in your head, you're like, sweet, I'm done. But I need your math to show me, sweet, I'm done. How is your math going to show me, sweet, I'm done? Yeah, you're going to go on the other side, you're going to say, see, look, they match. So without writing like a paragraph to tell me that, you're just going to write the other side. And then you're going to put QED, quote error demonstration, thus it has been proven. But if you don't want to be all snazzy and mathematical, you can put a check mark. Or George Corey back in the day 2 years ago, he wrote the rubber duckies. Someone else did a T-Rex. Someone else did, I don't need to know that. Something to show me that you are done. Does that make sense? And kiddos, guess what? They get hard. So we're gonna practice Monday and Tuesday. Sound good? Get out of here. Happy Friday.
I'm Steve.
Yay! Wait, are you still going for school little today?
Yeah, I'll be here Sunday.
I'm the way.
See you. Sorry. Thanks, Lucas.
After every problem that I completely don't understand, I just wait 2 minutes. Wait another minute.
Yeah, wait a couple of minutes and then you'll
Just to
be
say it
better
took you
when
longer.
you're
You're supposed to be trying for that time.
No,
Maybe
I'm just gonna-
pondering some of
I'm just
it.
gonna stare off in my
If
face.
you just sit on a problem making no progress for an hour, you're a